Okay, guys, lesson 5 inverse tables and graphs. All right, so we're working with inverse equations. So remember again, as always, I'm going to give you examples that are not your examples. So don't copy mine, please. Do your own. Do the one that's on the paper. Just follow the steps. All right, we can do this. You can do this. I promise. Okay. All right, so here we go. So we have y equals 1/3 x minus 2. What's the relationship between the table for the original function and its inverse? So we got to make a table. All right, but to do that, let's just graph it. All right, let's start with -2. And remember, that's your rise over your run. So up 1 over 3, up 1 over 3. Both directions, so I go down 1, left 3. All right, so let me complete that line now. There we go. All right, so I'm basically just going to use those points right there. So I got -6 and -4. And then right here I got -3, -3. Let's see, 0 minus 2. There's your y-intercept. 3 minus 1. And 6, 0. Okay, so now if you guys remember for inverse functions, the table is the same thing, just flipped around. So now I take all my y values, or f of x values, and they go here for x. That's the relationship with inverse functions. And then I take my x values, and now they become the y. All right. Okay, so there's that. So what's the relationship? Is x and y values switch. Okay, so now we're going to graph both of them. So I already graphed f of x. Now let's graph the inverse of f of x. Okay, so that's -4, 6, or -4, -6. Sorry, that'd be down here. Okay, then -3, -3. Then -2, 0. -1 and 3. And then 0, 6. Okay, so there's my inverse function. There we go. All right, great. Got them both in there now. You can see they almost kind of look like they're the same line, just facing the other direction, right? Okay, use algebra to find the inverse equation. All right, so remember, if you guys remember to do this, first I'm going to look at the original function and say, what would I do if I plugged a number into x? So if I plug something here into x, let's say an input, what would I do first? Well, the first thing I would do, let's say I plugged in 3 here. I would multiply 1 over 3. Now, when you multiply 1 over 3, I'm going to write that down here. That is the same thing as dividing by 3. So multiplying 1 over 3 and dividing 3, same thing, okay? The second thing I do is I would subtract 2. So now when I want to find the inverse function, I do everything backwards and opposite. So first I start with this. If I subtract 2, inverse, add 2. Okay, if I divide 3, inverse, I multiply 3. So I use that to figure out my equation. So remember, start with f to the -1 of x, okay, because that's the inverse notation. And the first thing I'm going to do is I would take my x and add 2. So I write x plus 2. And then I would multiply 3. So that means I would multiply everything here times 3. And if I want to simplify this, I could write this out. Let me write it right here. F of x equals 3x plus 6. Again, all I did was just distribute that 3. Okay, so now, does the graph of the two lines have a line of symmetry? If so, what is the equation of that line? Well, you could see that the line of symmetry is kind of somewhere right here, right? Somewhere kind of down the middle. And if I were to kind of graph these points on that line, you can see it follows all the way until it gets to that point, right? That's your y-intercept. So that's the b part of that. So I know it's a straight line. It's y equals mx plus b. And the y-intercept is 0. But what's the slope of that line? Well, the slope would be going up 1 over 1, up 1 over 1. So the slope is 1. So it's 1x plus b, or 1x plus 0. So if I simplify all that, I could take away the 1. I could take away the 0, and it's just y equals x. So that's the line of symmetry. And that's the line of symmetry for every inverse function. Okay, so you're always going to have that line of symmetry. Let's actually write that in. A little dash here. Okay, so every inverse function, guys, is going to have that y equals x. All right, next. Okay, so now we're going to graph this function and its inverse on the same set of x's. Okay, so the first thing we're going to do is come up with some points. Okay, now the first points that I know for sure out of this function is I can use the locator point. I know that the locator point, that point right in the middle, is going to be at +3. And there's no number outside here to the right, so that means it's 0. But I want a couple more points for this graph. I know that if it's cubed, it's going to be like one of these things, like that. But I just want a couple more points, just so I can kind of get an idea what it looks like and where to graph it. So let's use Desmos. All right, so I'm going to type this in. So I got f of x equals 1 divided by 3. You can use the, let me hide these down here. You can use this as well, move myself. If to get that 1/3, remember you could just do 1 and then click divide, and they'll give you the fraction. Okay, so then what is it? X minus 3. Okay, and then raised to, here's the exponent button, cube. All right, so let's get some points off of this thing. So we got that one, 3, 0. I'm going to kind of figure out a point somewhere up here. I'll figure out where it lines up. There's 5, but 5's not really like a whole number. I want a whole number. So let's go to 6. So 6 lines up. Let's see if I can get it to be a whole number. Oh, perfect, 6, 9. All right, so 6, 9 is 1. Okay, so let's write that down. All right, let's go back. And let's get a point going to the left. All right, so somewhere is 1. At 1, it's not really a whole number there. Let's go to 0, or x equals 0, where it crosses the y-axis. Oh, there we go. 0 minus 9. Okay, so the y-intercept. Okay, so 0 and minus 9. All right, so we got some points we can use to graph this thing. All right, so let's go ahead and graph it. So we got 3, 0 is that locator point. 6, 9 is going to be way up here. I'm just going to go ahead and put kind of a reference point, even though it's not on the graph. And then that 0, negative 9 is kind of way down here. Again, I'm just going to put a reference point so I know how to graph this thing. So do your best to sketch this thing out. So I know that it's going to, sorry, 0, 9 is actually right here, not over there. So here it's going to kind of come up. It's going to kind of level out, and then it's going to start going back up again. And then eventually it'll get up there, okay? So something like that, all right? Now, inverse. Remember, the inverse is I literally just take these points and I flip them around. So now this would be 0, 3, this would be 9, 6, and this will be negative 9, 0, okay? So now, let's graph those. So 0, 3, that's up here on the y-axis. 9, 6, well, that'd be like way out here somewhere. Okay, and then negative 9, 0. So negative 9, 0, somewhere about there, right? So I want this same shape, but now I'm going to go the other direction. So what I'm going to do is I'm actually kind of flip this around so I can get an idea what that looks like. So really what's happening is you're getting, it's coming up, leveling out here, and then making its way back here, okay? So now if I drew that same y equals x line of symmetry, right there, the same way I did that one, which is you just go through the middle and go up 1 over 1. Then you can see that it's pretty much a straight reflection over that line, okay? And you can actually use this to help you kind of graph it too. You could say, okay, here's my line of reflection. I kind of go over this far to get to that point, so I go straight across to get to that point. Or same thing with this one, I go straight from here all the way to there, straight from there all the way to there. Okay, so that's what the line of reflection shows you. Now, what is the inverse function? Okay, well, here we're going to do the same thing we did here. We're going to do a little algebra here. So what's the first thing I would do if I plugged in x? First thing I would do is subtract 3. What do I do after that? Well, then exponents come next. I would raise it to the power of 3. What's after that? Well, next I would multiply 1 over 3. Remember, like I told you, that multiplying 1 over 3 is just like dividing 3. Okay, so that's the original function, right? But now I need the steps for the inverse. So I'm going to go backwards, start with this one. If I divide 3, that means I multiply 3 first. If I cube something, what's the opposite of that? If you cube it, or let's say square it, right? The opposite of that would be to take the root, the cube root, or the opposite of square would be take the square root. So here we're going to find the root. And the last step, if I subtract 3, add 3. All right, so now let's write that out. So f negative 1 of x equals, first multiply by 3, so x, or 3 times x. Then whatever comes from that, I'm going to cube root that. So I'm going to take that thing and take the cube root. Now whatever comes from the cube root, I'm going to add 3. Now make sure that 3 ends up on the outside of your radical, or your radical sign. Don't put it on the inside, because whatever comes from this, you're going to add 3. So you don't want to include that on the inside. Okay, so there's your inverse function and your graphs. Okay, let me move this down a little bit so y'all can see that down there. All right, so now graph this function. Remember, I'm using this one, you're using that one, and its inverse on the same set of axes. Label it and state what is the vertex equation. All right, so what I'm going to do is I'm actually going to distribute this 3. So distribute it there, there, and I get 3x plus 3. So let's go ahead and graph that, okay? So I start at 3, and now my slope is 3, so it's 3 up 3 over 1, up 3 over 1. I don't have any room, so I got to go back down the other way. So down 3 over 1, down 3 over 1. Okay, so I'm going to go ahead and graph that line. And before I graph the next line, what I'm going to do is I'm going to graph that line of symmetry. Because remember, that line of symmetry is for every inverse function. So it's here in the middle, and it goes like that. Okay, so it goes straight down the middle like this. Okay, and I make it a dashed line because it's not part of the graph. Oh, that part down here is pretty ugly, isn't it? Not the greatest. Okay, did my best. Okay, so now let's list out some of these points. And remember, for a line, I only need 2 points to make a line, right? And then all I need is like a ruler or some kind of straight edge. So I'm just going to take 2 of these points. Let's take this one, -1 and 0. And this one, -2, -3. Now, all I got to do is flip those points around to get the inverse values. So flip that around, and now graph it. So 0 minus 1 is there. And then -3, -2 would be there. So there's 2 points that I can use to create my line. Now, if I want, you can see that the slope from that line to that line, from that point to that point, is up 1 over 3, up 1 over 3. So I can kind of just continue that pattern, or just find something flat. I'm literally going to find this like random like pencil lead holder and just use that as my straight edge. Find a pencil, a box, a book, whatever, okay? And now you can see there's a inverse function, which is if you reflect this one over that line, it becomes that line, all right? So now the last part is, what is the inverse function? Okay, so let's first look at this one and write out the steps. So the steps would be, first I would multiply 3, and then I would add 3. So the inverse, I'm going to start with -3 and then divide 3. So since it's y, I'm going to put y -1. And first I would do x minus 3, and then I take all that and divide by 3. Now I notice that these 2 numbers could be divided by each other. They're like the same. So what I'm going to do is I'm actually going to split this up. Let's actually do it down here. And divide the x by 3. And this is actually the same as, actually I'll show you guys in a second. And then divide this one by 3. Okay? And write it one more time. this is the same as saying 1 over 3x. And this is 3 divided by 3, which is minus 1. So now it looks like a graph that actually has information I can use and understand. Whereas like this, I'm like, huh? How do I graph that? Well, if you can simplify it, turn it into this. Okay, next page. Okay, so I got this function over here to the right, okay? And there's no like equation or anything. It's just a points with lines connected to it, okay? So that's your function. You're basically going to come up with the domain and the range of both the original function and the inverse function. Okay, so we're not like graphing the inverse of this. We're just going to come up with the domain and range. So what I'm going to do is I'm actually going to find out all the points. You can see I kind of did some erasing here. Don't hate me. All right, so that first point right there, that's -3 minus 2. And that next point right here for me is -1, -1. Remember, use your function, not mine. Next point right here, that's going to be 1 and -3. Sorry, not -3, +3. That next point here is going to be 3, 4. Okay. Now let's do the inverse. All right, so remember we just switched the points all around. So I'm going to take all these y's and put them here. And take all these x's and put them here. All right. Now what's the domain? So let's write down the domain of f of x. So domain of f of x, the original function, is what's the smallest x value, starting here, going to the biggest. So it goes from -3 up to 3. So I'm going to use set notation. So it goes from -3, comma, to 3. And those are closed dots, so we're going to do brackets here. And then the range, where it's going to go from -2 to 4. Or always start with your lowest value. And now let's look at the inverse function. Okay, so we'll look here. So here, for domain, you start at -2 and go to 4. You guys might start seeing a relationship here. And then for the range, I go from -3 to 3. Remember, I'm using that new table I made. Okay. Now notice, what do you see here? What is the relationship between the domain and range of the original and the domain and the range of the inverse? Well, the domain of the original is the range of the inverse, and vice versa for the range of the original to the domain of the inverse. So you can write that out in your own words, scribble, scribble, scribble. You write out what's the relationship here, like I just described. All right, now in this particular assignment, we're going to skip this one. It's a little too crazy. If you want to see that, I could show you another video. If you want it, just send me a message. I'll make a video about how to do that one, but not today. All right. Use the graph at the right to complete parts A and C below. State the domain and range of the graph. So let's start with the domain and range. Does it represent a function after we figure that out? So first, let's do domain. Okay, so remember domain, we go all the way to the left. What's the furthest left value? All the way to the left would be 1, 2, -3. And this time I'm going to use inequality notation. So put that x in the middle, right? And then all the way to the right, 1, 2, 3, 4, okay, is the furthest right value. Now on the left, I have a closed dot, so that's going to be less than or equal. If x is greater than, it's bigger than -3 or equal to it. But then over here, it's got a open dot, just like yours. Yours is open. So that means that x is going to be less than 4, but not equal to 4. Okay, so that's your domain. Okay, the range, we start on the bottom of the graph, and that lower value is -2. The highest value is 4. And remember, this is y now. And that lowest value is on the graph. It's a point like on the graph, so we're going to say less than or equal. And the point in the top is also on the graph, so we say less than or equal. Okay, so there's your domain and range. Does this represent a function? Okay, well, use the line test. If I had a vertical line and I moved it across, does it touch more than one spot as I go across? Mm-mm. Now, I know that my graph is terrible, that this is like straight down, and technically that would be not a function, but it's actually supposed to be like kind of like this one. It's sloped, but that's my fault. Whoops. All right, so this is a function, yes. And remember, we're using the vertical line test for that. Okay, so draw the inverse function of the graph. Oh, how do we do that? Take your points, just like we did before, and flip them around. All right, so I'm going to write down these points. So first I got -3 and 2. Oops. I'm writing down the original points first. Okay, then up here, this is going to be 1 and 4, or -1, 4. Then down here, that's going to be 1 and -2. And then right here, that's going to be 4 and 1. Okay, so now for the inverse function, I'm going to just flip those points around. 2 minus 3, 4 minus 1, -2 and 1, 1 and 4. All right, so I'm going to go ahead and graph those. Okay, so I got -2 minus 3 down here. And then 4 minus 1. 4 minus 1 there. And then -2, 1. And then 1 up 4. Okay, so now here's the tricky part. I've got to take this graph and kind of flip it over. So here, I'm going to kind of draw this little line of reflection. Okay, so what I'm going to do is I'm basically, this point is that point right here, right? So this point is the same as this point on the graph. It's just flipped over that point. And that means this point is the same as that point. So that means these 2 points are connected. Okay, they create that curve. Then it goes from this point over to this point. Remember, this point is that point on the other side of the reflection line. So these 2 points are connected. Okay, and then this point is also the same as that point, and which means I need to make that an open circle, and then these 2 are connected. So you just got to kind of follow, look at where the original point was, and then kind of reflect it over here, and then see how each point is connected. Okay, all right, so now state the domain and range of this graph. Okay, well, this graph goes all the way to the left at -2 for domain, and then goes all the way to the right at 4. Hint, hint. Remember that your domain and the range of the inverse functions are pretty much the same. And then the same thing vice versa for domain and range of the other one. Yeah, okay. So now the range, the bottom value is going to be -3, which it should be, this one, right? So I should expect that the top of that graph will be a 4. But again, the top is an open circle, so I use that sign, and then the bottom is just the closed circle, and I put y into it. All right. Is this, one part we forgot to do is this a function? Well, if I drew a line going straight down, you notice how it cuts through 2 points in the graph. It cuts there and there, so that means no, not a function. All right. All right, so that answers all those questions. Last part. All right, so let me make sure I got enough room down here for this last one. Okay, so solve the system. Okay, so here you notice right away this is in standard form. So we're thinking eliminate. Okay, so here I got these x's are the same value, but they're not opposite. So what I want to do is make one of them negative. So I'm going to take the top one and multiply it times -1. That way we get a negative equation, or negative x. So I distribute that -1 to every term. I'm going to basically bring it down here. So -x, then -3, then -15. Okay. That cancels x minus x. And then -4 minus -3y, -7y. And then 1 minus 15 is -14. divide by -7, and y equals 2. All right, now you got to find your x. Find x, plug it in. Take the 2, I'm going to plug it into this one. I'm going to plug in the first one. So x plus 3 times your y, 16. 3 times 2 is 6. Subtract 6. X equals 10. Okay, so my solution to that system is 10, 2. All right, remember yours is different. Do yours yourself. All right, now write a new system by replacing the x with x squared. So wherever you see x in your system, I'm just going to put x squared instead of just x. Okay, so it'll be x squared plus 3y equals 15. And then x squared minus 4y equals 1. Okay, so now, same steps as before. Even though it's x squared, I'm still going to basically eliminate that x. Okay, so because I'm going to solve it, I'm going to leave myself just a little bit of room just so I don't make sure I don't run out of space here. I'm going to solve it right here. So let's go ahead and multiply to this times -1. And guess what? It's going to be pretty much the same thing. Just I'm going to have a negative x squared this time. That becomes -3. That becomes -15. And guess what? That cancels. If that cancels, that pretty much is the same equation again. -7y and -14, which I know if I divide 7, it's going to give me 2 again. All right, the next step is where it gets a little different. Now I got to plug that back in, right? So let's plug in the same equation I did before, this one. So now it's x squared this time, plus 3 times 2 equals, oops, I just realized on this last one that I put 16 there. How come nobody told me? Oh yeah, it's because I'm by myself. I'm quarantined. No, I'm not. I'm just kidding. I'm just kidding. I'm just kidding. I'm in the classroom by myself. Okay. That's why I have no mask. All right. There's no one in the room. I'm socially distanced. All right. So then 15 minus 6 would be 9. So this is actually a 9. All right. You will not get the same answer over here. Okay. So now this equals 15. Okay. So now I'll get 6 here. And then I'm going to subtract the 6. And you're like, yes, you did. You got 9. No, I didn't. Because it's x squared equals 9, not x equals 9. Remember how you solve an x squared problem. You square root both sides. Square root here, square root here. So x equals both 3 and -3. Okay? And just so people don't get confused, because sometimes when I write a comma like that, you guys think it's a point and you put parentheses around it. Don't do that. It's 2 separate answers. It's 3 and -3. You can do a comma, just don't put parentheses. Now, so what that means is that when x is 3, the y is 2. But also, when x is -3, it's also 2. So you have 2 solutions to the system. And let me show you why. So if I graph these 2 equations, so I'm just going to take my original equations, x squared and don't want that, plus 3y equals 15. Let's pull that down a little bit. And then same thing, x squared, well, almost the same, minus 4y equals 1. Notice here's those 2 parabolas. They cross right there. There's your solutions, -3, 2, and 3, 2. So you could be doing this to verify your answer, right? So if you want to check to make sure you got it right, then look right here in Desmos. Type in both of your equations. And you can do this for both this parabola, and if I take the square away, that's my original one. That was like the problem 1, right? And now I can verify to make sure that that was 9-2 was correct, because that was the first answer we got in the first one down here. Okay, that's it. Where did everything go? Oh, there it is.